So section 3.2, we've already basically done 2 of the 3 methods. So section 3.2 is how to solve quadratic equations. So one is if it's factorable, let's use the AC method. Another one is if they don't have the x in the middle, we can use the square root method, where we just move the constant over and take the square root of both sides. And we add that plus or minus in front, remember that? And then the last method, which we have not done yet, is a quadratic formula, okay? So this is just showing you that a quadratic equation, again, we've seen it over and over again, is ax squared plus bx plus c equals 0, where a is not 0, all right? And it can be written in, this is called standard form. So some examples are like here, mid. This is your typical, you have your a, you have your b, you have your c. This is a quadratic as well because it has that x squared term, but this is how we would solve using the square root method, where we move the 10 over, divide by 2, and take the square root. Both of these are solvable. Oh, is that solvable a word? I don't know. Okay, solvable. This one's factoring. This one's the square root method. But sometimes you'll get one where you just get stuck. It'll look like this, but it just does not factor. How can you go about solving it? This beautiful formula, the quadratic formula. How many of you guys have seen this before? You guys see that in the algebra class before? I didn't know until I started teaching college algebra that someone said in their high school math class that you can sing it to Pop Goes the Weasel. Like, do, you know what I mean? X equals negative b plus or minus square root and something like that.
That just gave me like a flashback. We did that.
Come back a couple years, okay? So what it is, it's someone who has gone in and completed the square and solved for x using a different technique and said no matter what your a, b, and c are, x will always be found using this order, okay? So b will always be negative, that's just part of the formula. Plus or minus kind of gives us that square root property, right? When you square a negative, it's positive. When you square a positive, so we're going to have him. We have b squared minus 4ac, and it's all over 2a. So keep that in mind because a lot of people get sloppy and they start just doing the square root over 2a. The entire thing's over 2a. All right? When you plug in a negative for b, it becomes positive, right? Like, so if you have a negative there because of your formula, but your b is a negative 2, that will become a positive 2 there. When you square a positive or a negative, that's going to be positive no matter what. And this part's kind of where signs will start kind of getting iffy depending on whether you have a positive a or c. Okay, so let's go ahead and do it. So he's kind of like your no-fail method. If you notice it factors, yay, do that. If it's really quick, do it. But if it's like, okay, I don't really know what the factors are, or I don't want to spend time on the factors, your quadratic formula will always get you there. It's a little bit more time consuming than factoring or the square root method, but it's kind of the no-fail method. All right, so, and that's what it says. It will always work. You can use this anytime. All right? This is just the AC method, if you want to make note of all these things, where we do that zero product property, right? You factor it to 2 things, and A or B is 0. All right, so let's go ahead and look at how we can use this. The first method, notice that the x is simply disappeared, right? We do not have our x terms. So what method should we use on that? Should we use factoring, the square root method, or a quadratic formula? Yes, this is, I call it the square root method or the square root property. If your middle term x has disappeared, you can isolate your constant and just take the square root of both sides. So what are we going to do first, guys? Add 10 over. So you have 2x squared equals 10. And then what's your next move? Divide by 2. So you have x squared equals 5. And then how do you undo squaring? You square root. But remember, when we do the square root on the right side, what do we need in front of the square root? Plus or minus. Okay? And that just shows us that there's 2 answers. When you take the square root of 5 and square it, multiply by 2, you'll get 10. 10 minus 10 is 0. But when you take the square root of negative root 5, square it, it'll still be a positive 5 times 2 is 10 minus 10. So both of those are your answers. So x will be plus or minus the square root of 5. If 5 could break it down, but 5 doesn't, so it can stay under the root. This method is the only method when you don't want it set to 0. You move the constant over. The other 2 methods, factoring and the quadratic formula, you want everything to one side in the right order, set equal to 0. So notice we do have an x in this one, so we don't want to use the square root method. So I want to get everything to one side, so my first move is going to be subtract the 3 over. And since he's the only constant, he'll just go in the back. Okay? So if the x term is there, so notice on 1 there's no x term. There was an x squared and there was a constant, right? If the x term is there, you need to move everything to one side equal to 0, so you either can see if you can factor it or use the quadratic formula. When the x term is missing, this is the only time that you actually move something over to the other side and start to isolate x, all right? So this is how you're going to go about doing it. On a test or on your homework, it'll say solve for x. The first thing you might do is try to factor. What's the AC method? Your A is 2, your C is -3. So what are factors of -6 that add up to -1? -3 and 2. If you can do it that quick, do it. Factoring is going to be quicker than the AC or the quadratic formula, okay? So you say, okay, -6 splits up as 1 and 6 or 2 and 3, right? And which ones differ by 1? The 2 and 3. So I'm going to have 2x squared minus 3x plus 2x minus 3 equals 0. Because our AC was -6, correct? So what can we factor out of the first two terms? X, and we're left with what?
2x minus 3.
Perfect. And notice on the back, we have 2x minus 3, so what do we need to factor out? A plus 1. That way, when we see the two terms, we notice they have a common factor of 2x minus 3 that can be factored to the front, but what's our remaining binomial? Perfect. And that 1 lets us know that, hey, we factored out a 2x minus 3 there as well. All right, so zero product property. Take each of those, set equal to 0, and solve for x. Sorry, my lead's going crazy. Okay. So this one, you move 3 over by adding, correct? And then you divide by 2. So this would be x equals 3/2. I know I skipped a lot there, but you'd add 3 over and then divide by 2. On the right one, it'd just be x equals -1. Could you solve it this way? No. But could you solve it using the quadratic formula? Yes, it might just be a little bit time consuming. Let's look at this next one. Again, notice I have an x term on number 3. So since I have an x term, I can't just ignore it and take the square root of everything, right? So I cannot use this method. If you cannot use the square root method, you need to move everything to one side and get it equal to 0. So 3x squared plus 2x minus 7 equals 0. Quickly look at the AC method. 3 times -7 is -21. Are there factors of -21 that add up to 2? No, because 21 splits up as 1 and 21. So that doesn't get you to 2. And 3 and 7 will get you to 4, right? You're not going to get to that 2. Well, and before you go, I'll just give you this, just in case you don't come back. Okay? Because we're only going till 2:40, right? So if you're going to come on back. Otherwise, work on that. All right, so that doesn't work. And so what we're going to use is the quadratic formula where we need to identify A, B, and C. So in this case, A is 3, B is 2, C is -7. So we're going to use the quadratic formula. I'm going to write it generically at first. -b plus or minus square root, b squared minus 4ac all over 2a. The more times you can write it generically, the more you'll kind of just memorize the formula in your head. You'll want to know it for the test, okay? All right, so we're going to plug in our b, our a, and our c. So we have x equals -2 plus or minus square root 2 squared minus 4 times a, which is 3, times c, which is -7, all over 2 times a, or 2 times 3. Okay? So my b had to be negative. So my b was a 2, so I plugged in a 2. So I have -2 plus or minus b squared, but my b was 2, so 2 squared. I always put that in parentheses. That way, if it's a positive or a negative, I know when I square it, it's going to be a positive. Minus 4, 4 is part of your answer, times a, which is 3, times c, which is -7, all over 2 times 3. So what I do next, guys, is I let the -2 hang out, and then I put this in my calculator exactly how I see it. All right, so don't worry about the square root yet, okay? Leave the square root alone. Just plug in what you have underneath. So 2 parentheses squared minus 4 times 3 times -7 And when you do that, did you guys get 88? Okay. So then it's going to be 88 over 6. Does that look okay so far? So when they ask for you to do this and they want an exact answer, they want that answer to be reduced. What do I mean? They would not take that as an answer because the square root of 88 can be simplified. So off to the side over here, I'm going to do my little factor tree. What are two numbers that multiply to be 88?
4 and 22.
4 and 22. Why does that help us? Because the square root of 4 is 2. 22 just splits up as 2 and 11, correct? So what does that mean? Who can come out? The 2, right? So right here, the 2 will come out, and who has to stay in? 2 times 11, or 22. So this actually is negative 2 plus or minus 2 comes out, 22 remains, all over 6. Is that okay so far? So it's using all those skills we've used up until now. Last thing, when you get to this and you see the 3 parts all have a common factor, you can reduce it. What do I mean? It means the constant in front, your negative b, has to have it. The coefficient for your root has to have it. And your denominator has to have it. So a lot of people, like if this didn't have a 2 there, you could not reduce it any further. Like if he was just root 22, you would be done. But if all 3 parts have that common factor, you can reduce it. So do you agree that all 3 parts have a common factor of 2? So this will just reduce to, well, what's negative 2 divided by 2? Negative 1 plus or minus. What's 2 divided by 2? Just 1. But I'm not going to put a 1. I'm just going to put root 22. Is that okay? And then what is 6 divided by 2? 3. But again, keep in mind, all 3 parts have to have the factor in order for it to reduce. If that was just negative 2 plus or minus root 22 over 6, you'd be done. And I'm skipping what we're doing there. Technically, we're factoring out a 2 in front and leaving that remaining and then canceling the 2 with the 6, okay? So let's do the same thing, guys. It says try, but let's just go ahead and do it. Notice again, we have an x term, so we can't use the square root property, so I'm going to move the 15 over. And then you just quickly look at it, give it a quick glance. Your a is 1, your c is 15. So 1 times negative 15 gives you an AC of negative 15. Is that one factorable? Do you have factors of negative 15 that add up to negative 2?
Yeah.
You do. So that's the way I go. If you like the quadratic formula because it works no matter what, do that. But I think that the factorings, I don't know. Maybe it's because I'm a teacher, so I like factoring. So we'll do x squared. And then what are the factors that get us to negative 2x? 3 and 5, which one's positive, which one's negative? Negative 5x plus 3x minus 15 equals 0. Look at your first 2 terms. We can pull out an x, so that will leave you with x minus 5. Look at your back 2 terms. We can pull out a 3, and that will leave you with x minus 5. So our 2 terms have a common factor of x minus 5. Pull him out in front is your remaining binomial x plus 3, guys. Does that look okay? All right. So the zero product property says take each of your factors and set them into equal to 0. So the 2 answers I get are 5 and negative 3. All right? This was not factorable, and notice how ugly our answer is, okay? So with the quadratic on number 3, it wasn't factorable, so you're going to get an ugly answer. If it's factorable, even if you use the quadratic formula, this square root will break down perfectly, and you'll be able to combine it with the number in front, and you'll be able to divide by 3. All of it will work here to get you these 2 nice, pretty numbers, okay? Let's look at example 5. Notice on example 5, the x term is gone. So what method are we going to use there? The square root method, where you're going to move your constant to the other side. So we'll subtract our 64 over. So you have 4x squared equals a negative 64. What's my next move? Divide by 4, right? Because we want to get the square by itself. So we're going to divide by 4. So we'll have x squared equals a negative 16. Is that what you get?
Yeah.
And then, how do you undo a square? You take the square root. But when we take the square root, guys, we're going to make sure we put a plus or minus in front of that square root. All right, on the left-hand side, that square and that square root always cancel out to pop out what was in there. So in this case, it was an x. Over here, you always have the plus or minus, and however that root like simplifies will be behind the plus or minus. So what is the square root of negative 16? Well, what do we do with the negative? It becomes I, and then what's the square root of 16? 4. So this is plus or minus 4i. Or if you want to in my math lab, they should take 4i, comma, negative 4i. So if you want to split it up and not use the plus or minus symbol, just put a comma in between your two answers. All right, last one here, guys. Notice we do not have that middle term gone, so we want to get everything to one side. You don't have to, but typically I like to keep my x squared term positive. So I'm actually going to move the 8x and the 9 over to the other side. So x squared will stay x squared. The 8x will become a negative 8x because I subtracted it over. And the 9 will become a plus 9 because I added it over. Is that okay? And you don't have to do it that way. If you're like Molly, I'd rather move just one thing over. But just when your a is negative, it just kind of gets complicated. All right, so look at this one. Is it factorable? Are there factors of positive 9 that add up to negative 8? You want to say yes at first because you think 9 and 1, right? But in order for 9 and 1 to get you to a negative 8, the 9 needs to be negative and the 1 would need to be positive, correct? And those two multiply to be a negative 9, not a positive 9. So there's no way to factor this, so we have to use the quadratic formula. So we do x equals negative b plus or minus square root b squared minus 4ac all over 2a. And again, the more you write it generically, the more you'll get it in your head. So our a technically is a what? 1. Our b is a negative 8. And our c is a 9, okay? So our a is a coefficient in front of our x squared, so that's 1. Our b this time is a negative 8, and our c this time is a constant, all right? So when I go to plug it in, I have negative of b, but b is negative. So I filled it in like that, but if you know that you're plugging in a negative for a negative, and that becomes positive, feel free to just put a positive 8 there. That's fine. Plus or minus the square root of negative 8 will be in parentheses. I'm going to square it, so I'm going to make sure I get a positive 64 there. Minus 4 times a, which is 1, times c, which is a positive 9, all over 2 times a, or 1. All right, so we'll just go back and clean stuff up. The negative with the negative will give us a positive 8, plus or minus, and then I'm just going to put this in my calculator and see what exactly I get from my square root. So parentheses, negative 8 squared, make sure that's in parentheses, minus 4 times 1 times 9. Since all the back ones were positive, I don't really worry about parentheses there. Did you guys get 28 for underneath your root? Does that look okay? So that will just be 28 over 2 times 1, or 2. So again, at this point, you do have an answer. It's just not a reduced answer, meaning your radical is not simplified, and then once you simplify your radical, you might be able to simplify the whole thing. So over here, wherever you need to, do a little factor tree. What are two numbers that multiply to be 28? 4 and 7, and why that helps us is because 4 is a perfect square. So 2 will come up, 7 will remain. So this will be 8 plus or minus 2 root 7 all over 2. Is that okay so far? And then again, stop and ask yourself, can you reduce it further? You can, because this term, and this term, all three have a common factor of 2. And since 2, like this bottom, like basically 2 goes into 8 4 times and 2 goes into 1 time, you don't even have a denominator in this answer, right? So this just reduces to 4 plus or minus root 7, correct? Because that would go to a 4, that would go to a 1, that would go to a 1, and you don't typically say over 1. Is that okay so far? All right, so let's just look at this last page here. It's getting into, well, what are we finding when we're solving these quadratics? Well, we're actually finding the zeros of functions, which means where do they cross the x-axis? So if we were to graph this function, guys, it's crossing the x-axis at positive root 5 and negative root 5, whatever that is, like 2 point something, right? If we graph this quadratic, the parabola is crossing at 3/2 and negative 1. So sometimes when we do this, we get ugly answer, which is fine, but we can also do it using our graphing calculator, okay? So remember, we could use our graphing calculator to find max and mins. You can also find it where it crosses your x-axis, which are called zeros. So it says, solve 6x plus 1 equals 4x squared for x graphically. Approximate your solutions by rounding to 3 decimal places where appropriate. Note, a solution is just the zero of a function, aka an x-intercept, okay? So what we would do is we would graph this, and then we would just see where it crosses the x-axis. What we want to keep in mind is this is nowhere close to the correct form, right? So again, I like to keep my x squared positive, so I'm going to keep 4x squared over here, and I'm going to move the 6x over and the 1 over. So my equation is going to be 0 equals 4x squared minus 6x minus 1. Does that look okay? So what we're going to do is we're going to use our calculator. If you want to, real quick, throw it in your head, but factors of -4 don't add up to -6, so it's not factorable. So you'd either have to use the quadratic formula or your graphing calculator. So in our graphing calculator, guys, let's go to our y equals feature, clear out anything that may be in there, and type this parabola. 4x, and then the squares over here, minus 6x minus 1, okay? And then you'll hit graph. And mine's on the standard. If yours isn't, remember you can always hit zoom, and then standard is number 6. So notice it's crossing the x-axis close to 0 and close to 2, but not exactly. So how do we find it? Anytime you want to do something with a graph, whether it's max, min, x-axis, whatever, we're going to use this calc feature, so second trace. And what we want to find is we want to find zeros, all right? So we're going to pick number 2. When we go to do it, it's kind of like your maximum minimum. Where the max and min occurred, remember you had to do like a left bound and a right bound. It's going to be the same thing here. So we know these zeros happening right here, so we need to go above it to come up with a left bound, and we need to go below it to come up with a right bound. So arrow to the left until you're above the x-axis, and your cursor is to the left of your intercept, and you hit enter. And then pass the x-axis to go below, or aka to the right of your 0, hit enter. And they give you these little arrows up top and say, okay, you want me to find somewhere between these arrows where we hit the x-axis. So it says guess, question mark, and we're going to say yes. So we're going to hit enter. And notice it gives us a 0. And like I said, the 0 is really, you can't see it, sorry. The 0 is really close to 0, which we thought, but it's a little bit more exact. So rounding to 3 decimal places, what is that answer? That is x equals, did you guys get negative 0.151? Did you guys get that to work on your graph? Okay, perfect. And then we're going to do a comma. Why? Because our graph also crosses over here close to 2. So we're going to go do the same thing, but keep in mind as you move left to right here, you're technically under the intercept when you're on the left and above the intercept when you're on the right. So we're going to hit second trace. We're going to hit the 0 feature 2, and I'm going to scroll till I'm to the left technically of that intercept. So I'm going to hit enter. I'm below it. I'm going to hit enter. And then I'm going to keep hitting to the right until I cross over and hit enter. And again, it gives you these 2 little arrows that says somewhere in here we cross the x-axis. Do you want me to find it? And I'm going to hit yes. And you should get 1.651. Is that what you guys get? Okay. So keep in mind, some people want to argue like, oh, do I always have to be above it or below it? No, it just depends with your graph. As you move left to right, sometimes you're above it on the left bound, sometimes you're below it on the left bound. So again, how did we do that? We graphed it and our y equals, and then we hit second trace, which was calculate, and we used 2, which was zeros. Okay? All right, so these are our answers. So guess what we could have gotten? We could have gotten these answers as well using the quadratic formula. So we're learning plenty of ways to solve for a quadratic. All right, so that's it as far as solving goes. The next chunk is getting into the discriminant. So the discriminant, guys, is just that part underneath the root. So this b squared minus ac is your discriminant. And depending on what type of number under your square root, guys, we'll know what kind of solutions we have. So everything I gave you was a nice positive number. We had a root 22 and we had a root 7. Or those are the only times. So we got 2 answers, right? We got a plus and we got a minus. So if your discriminant, guys, is a positive greater than 0, we're going to have 2 different solutions. But say it was 0. So let me give you an example, guys. Write this example down. Say we find x, and x is 2 plus or minus root 0 over 6. That's how what we got when we used the quadratic formula. Well, what's the square root of 0? 0. So do you really have a plus or minus part? No, you just have 2 plus or minus 0 over 6, which is just 2 over 6, or x is just 1/3. So you only have one answer. So notice if your discriminant equals 0 perfectly, you only have one solution. What does that mean? It means if you were to graph this bad boy, his vertex would sit perfectly on the x-axis, okay? So if your discriminant is 0, so b squared minus 4ac, we don't have to do the other crap at all. We can know what kind of solution we have there. Now, if your discriminant is greater than 0, then we're going to have two real solutions. Let me give you an example there. Let's write that down. So say we have x equals 2 plus or minus the square root of 10 over 6. What kind of answers do we have there? We have two, right? One where we take 2 plus root 10 over 6, and one where we take 2 minus root 10 over 6. So we have two answers, 2 plus root 10 over 6 and 2 minus root 10 over 6. So whenever you have greater than 0, you have two real solutions. And what does that mean if we graphed it? It means it just crosses the x-axis twice. And that's most of the time what we're going to see. All right, last thing. This did not come up in our problems, but it could have, and you guys could have handled it fine. What happens if your discriminant is less than 0? That means it's a negative under your square root, which means you have two imaginary complex conjugates, okay? So an example of that, let's just say we have x equals 2 plus or minus the square root of negative 4 over 6. Well, how would that break down with having a negative? That would be 2 plus or minus 2i over 6, which reduces to 1 plus or minus I over 6. So notice that if you have a negative, the I pops out, so we're now in an imaginary or complex number system, but we still do have the plus or minus part, so we do have 2. What does that mean? It means in our normal graphing coordinates, we don't cross the x-axis in our normal coordinate system, x comma y. All right? So if you understand that, will you do this bottom example with me, example number 8 on the bottom of page 3. It says, find the discriminant, b squared minus 4ac, and then determine whether we have one real solution, two real solutions, or two imaginary solutions. So notice it doesn't even care what the solution is. It just wants to know the number and the type. So let's put this in order first. So we're going to have 5x squared minus 4x minus 11 equals 0. Let's label our a of 5, our b of negative 4, and our c of negative 11. So we're going to do the discriminant, b squared minus 4ac. All right? So we're going to plug in our b, which is a negative 4. So we have negative 4 squared minus 4, which is times a, which is 5, which is times c, which is a negative 11. And again, I'm going to put that in my calculator exactly as I see it. So when I type that in, all at once with parentheses where I need to put them, you get a positive 236. And what does that mean? It means we have two real solutions. Why? Because that is a positive number. What does that mean? He's under the root, so we do plus or minus whatever the square root of 236 is. Plus it would give us one solution, minus it would give us a second.